For nearly 30 years, one image has defined modern astronomy: the pillars of creation. These towering clouds of interstellar gas and dust, frozen in a snapshot by NASA's Hubble Space Telescope, are far more than a breathtaking visual. They are a living, breathing, stellar factory, quietly churning out new stars at the heart of the Milky Way. Today, we travel 6,500 light-years from Earth to the core of the Eagle Nebula, catalogued as Messier 16, to uncover the full story of these celestial pillars. We will walk through their discovery, break down the physics of star formation hidden within their folds, examine the revolutionary new views from the James Webb Space Telescope, and grasp what these pillars teach us about the endless cycle of creation that defines our entire universe. This is not just a tour of a distant nebula. It is a journey to understand where stars come from and where we come from too. The story of the pillars of creation begins long before humans ever saw them. The Eagle Nebula, home to these pillars, sits in the constellation Serpens, a bright star-forming region, visible with small backyard telescopes in late summer nights. For centuries, astronomers knew it as a fuzzy cloud of light, but they had no idea of the dramatic structure hidden at its center. All that changed in April 1995, when astronomers Jeff Hester and Paul Scowen pointed Hubble's Wide Field and Planetary Camera 2 at this tiny patch of sky. The image that came back stunned the world. 3 towering dark columns rose against the glowing backdrop of pink and blue gas, sharp and detailed, like nothing seen before. The tallest pillar stretched 4 to 5 light-years from base to tip, more than 200,000 times the diameter of our entire solar system. Overnight, the pillars of creation became Hubble's most famous image, printed on posters, textbooks, and even postage stamps, a universal icon of cosmic wonder. But what exactly are these pillars, and why do they look the way they do? Let's break it down, simply in true NASA fashion. They are made almost entirely of cold molecular hydrogen, about 90%, mixed with helium, and tiny dust grains rich in carbon silicon and other heavy elements. This is the raw fuel of stars. The pillars do not exist in isolation. They are dense pockets of gas that have survived intense radiation from a cluster of massive hot young stars just outside the frame. Those giant stars blast out fierce ultraviolet light that blows away the thinner, weaker gas around them, a process called photoevaporation. Like rocky buttes in a desert that outlast softer rock around them, these dense pillars remain standing while their surroundings erode into space. The same radiation that carves their shape also lights up their edges, creating the glowing ethereal colors that make them so visually striking. Every wisp, every ridge, every shadow tells a story of cosmic forces shaping matter on the grandest scale. Deep within these pillars, astronomers have discovered tiny dense clumps, called evaporating gaseous globules, or eggs for short. These are the direct cradles of newborn stars, each one a compact cloud, just big enough to collapse under its own gravity. Hubble first spotted these eggs in 1995, but they appeared as small dark dots, with little internal detail. For years, scientists could only guess what was happening inside these stellar eggs. They wondered how quickly they would form stars, how massive those stars would become, and whether any of them would one day host planets of their own. This missing piece of the puzzle left a huge gap in our understanding of how stars begin their lives in such active, radiation-filled environments. Now, let us step inside the pillars to see the real magic, the birth of a star. Deep within the coldest, densest knots of gas and dust, gravity takes hold. Tiny clumps of material begin to collapse inward, pulling more and more gas toward them as they grow. Over hundreds of thousands of years, the core of each clump heats up and compresses until it reaches temperatures of millions of degrees. At that moment, nuclear fusion ignites, and the new star switches on for the first time. But the process is not clean or quiet. As a baby star, called a protostar, grows, it forms a spinning disk of gas and dust around it, known as an accretion disk. This disk feeds the star more material while blasting twin jets of superheated gas into space at hundreds of kilometers per second. These jets carve channels through the surrounding cloud and create wavy, flame-like structures along the pillar's edges, visible even in Hubble's original images. Webb's infrared vision has changed everything we thought we knew about the pillars of creation. Where Hubble saw dark, opaque walls of dust webs, near-infrared camera peers straight through, revealing hundreds of hidden protostars we never knew existed. In 2022, Webb's new image showed the pillars as semi-transparent, glowing orange and brown, with bright red infant stars dotting their edges like cosmic embers. Scientists have now identified more than 250 young stellar objects inside and around the pillars, proving this is one of the most active, star-forming regions in our nearby galaxy. We can now see the exact spots where stars are emerging from their dusty cocoons, ready to join the galaxy's stellar population. This is not just better imagery, it is a complete revolution in how we study star formation. Webb's data also lets us measure the temperature, density, and motion of the gas inside each pillar, giving us a real-time map of how stars are built. You might wonder how long these pillars will last. The truth is both poetic and humbling. The same ultraviolet light that shaped them is slowly destroying them piece by piece every single year. Photoevaporation strips away gas, equivalent to multiple Earth masses annually, and over the next 100,000 years, the pillars will gradually erode and fade away entirely. There is even evidence that a supernova explosion thousands of years ago may have already sent a shockwave through the nebula that will eventually tear the pillars apart. Though, because light takes 6,500 years to reach Earth, we have not seen that destruction yet. But here is the beautiful twist. By the time the pillars are gone, the stars they created will be fully formed, shining brightly, and nurturing their own planetary systems. The death of the pillars is not an ending. It is the beginning of the next generation of cosmic life. This cycle of creation and destruction is the heartbeat of the universe. Stars form in clouds, like the pillars of creation, live for millions or billions of years, and die in spectacular supernovae that scatter heavy elements into space. Those elements then become new clouds, new stars, new planets, and eventually living things. The carbon in our cells, the oxygen we breathe, the iron in our blood, all of it was forged inside stars that were born in nurseries, just like this. When we look at the pillars of creation, we are not just looking at a distant nebula. We are looking at our own ancestral home in the cosmos. We are made of stardust, and these pillars are where that stardust is made. The pillars of creation also teach us a powerful lesson about exploration. For decades, we saw only what Hubble could show us. Then, Webb opened a new window, and the story grew deeper, more detailed, and more amazing. Every time we build a better telescope, every time we look closer, the universe reveals more of its secrets. There are still countless questions left to answer. How many planets will form around these new stars? Could any of them support life? How do stellar jets shape the future of star formation? Ground-based observatories, like the Very Large Telescope in Chile, work alongside space telescopes to cross-check and enrich these findings, creating a global effort to decode the universe's greatest mysteries. The pillars of creation remain a living laboratory for astronomers, a place where we can watch the universe build itself in real time. As we wrap up this journey, take a moment to appreciate the scale and the silence of these pillars. They stand in the emptiness of space, cold and ancient, working quietly to create new suns. They remind us that the universe is not just empty and dark. It is dynamic, creative, and full of life. We are lucky to live in a time when we can see these wonders, study them, and share their story. The pillars of creation are more than an astronomical phenomenon. They are a reminder that creation never stops. The universe is always making new stars, new worlds, and new possibilities. And we are all part of that endless, magnificent story. Please like, comment, share, and subscribe to the channel.